All right, so if you have a parabolic mirror, mirrors are pretty cool in general. Hopefully, you're comfortable with the law of reflection. If I had like a mirror and I had a light ray coming in, then there would be an incident angle, and I forget if it's measured from the vertical or the horizontal, but whatever that angle is, the reflected ray would have the same like angle measured from the vertical, or if this is the angle of incidence from the horizontal, right? Hope it would be the same angle. That's the idea. It's a perfect reflection. This is the reflected ray. This is the incident ray. So if you had light, let's say you had this, let's say you had it like this, right? You had a mirror like this. If you had light coming straight, like perpendicular to the mirror, or, parallel to like a principal axis, right? If it was coming straight perpendicular to it or parallel to the normal or whatever, the principal axis, the light would just reflect like straight back, right? Like it's pretty simple stuff. Well, if you had a parabolic mirror, and you had light going parallel to the principal axis, and the principal axis is like for something like a parabola, it's like the axis where you cross the vertex and the focus, or like the center. So it crosses the vertex and the focus. If you had light that is parallel, like a light ray parallel to this principal axis, that light will reflect to the focus without fail. I could have light coming like so, and it would still reflect back to the focus. As long as it's parallel to the principal axis, light does this. And what I'm gonna do is show you why that is mathematically. And the reason why, like conceptually, is if you zoom in to the parabolic mirror, right? It's curved. But if you zoom in to, let's say, this point right here, like that point right there, the mirror at that specific point, when you're super, super, super zoomed in, is essentially straight. Like if I zoomed it in, it's essentially a line. And if you've taken calculus, that line we sometimes refer to as the tangent line. So if I think about the mirror, if I had, let me draw that back in, I could draw a line that is tangent to the curve, which touches it at that one point. And for that line, the law of reflection follows. Like if you were to take this angle, theta, it would equal this angle, theta. And what you're going to find is, as long as the light is parallel to that, to the principal axis, when it reflects off that tangent line, it always goes back to the focus point. Here is how I'm going to prove that to you. So, this tangent line is going to have a certain slope, and that slope is going to equal the derivative of this curve. So this curve is it's a horizontal horizontal parabola. And if you've taken conics in pre-calc, you know that for this kind of a curve, it's equal to x is equal to 1 over 4f times y squared. You can derive this by a definition of the parabola. It's a curve where all the points are equidistant from a focus point and a directrix. And the focus point is going to be a distance f from the vertex. So this is the equation of a horizontal parabola. If you've taken pre-calc, this should be covered, I think, conics. I remember it being covered. And now you just take the derivative. So I could do d of dx on both sides. I'm doing, I think, what is this, implicit differentiation. I can do d of dx on both sides. And I get 1, right, is equal to 1 over 4f. D of dx y squared is going to equal times 2y times dy dx. Solving for dy dx, I get 4f over 2y. Or I get f, or like 2f over y is equal to dy dx. So dy dx. So if I know the y point, that's going to be the derivative. If I just plug in that y, I get the derivative at that point. So let's think about, let me redraw this just so it's a little bit nicer, and we're going to focus on one light ray here. So if I draw my little mirror, and I get I just want to draw an axis just so we're grounded and we know where things are going on. Let's say I have light coming in parallel to the principal axis, and it hits it at a point x, y, right? So now the reflected ray will have a certain slope. Now you might be saying, oh, I wonder what that slope is, right? That's what this equation is. That's why I wrote this equation. I forgot some ones, but that's what this equation is. I derived in my last video. It took 30 minutes and it was painful, but this is a derived equation. You don't really have to worry about where it comes from. In fact, M initial is referring to the tangent line itself, that the line of tangency, the slope of that, which is really this derivative. And M1 is referring to the slope of the incident line, which in this case is just 0. So this term crosses, and you essentially get M2, or the slope of the reflected ray is equal to 2MO over 1 minus MO squared. So MO, or M initial, M naught, whatever, M naught is just the derivative at that point. So I can say, well, M is going to equal 2 times the derivative. So 2f minus over y times 1 minus 2f over y squared. Or I get 4f over y divided by 1 minus 4f squared over y squared. I can use some fractions, right? I could say that, okay, this is going to equal 4f over y times, so this right here is going to equal y squared. So this is really equal to y squared minus 4f squared over y squared. Hopefully you can see why. I can make a common denominator with the 1, y squared over y squared, and I get that. So then I can just do the reciprocal of that, right? Multiply by the reciprocal, I get y squared over y squared minus 4f squared. In other words, I just get 4fy over this y crosses. So I just get 4fy over y squared minus 4f squared. So that is the slope of this line. So if the claim is true, if light that reflects from a light ray parallel to the principal axis, if it's true that it hits the focus, what that means is, if this point is FO, right, where F stands for the distance from the vertex to focus, then from this point to the point that the light hit, the slope, if I did right, remember slope by definition is y1 minus y initial over x1 minus x initial. That, or in other words, y minus 0 over x minus f, that slope needs to equal the slope of this line that I computed from my derived equation. So it would have to equal 4f y over y squared minus 4f squared. And since we're talking about pre-calc so much, let's do a pre-calc style proof. We'll say that the left-hand or right-hand side is equal to y over x minus f. X, what is x? Well, it's just x right here, right? X is equal to 1 over 4f times y squared. That is, like, by the equation, what x is equal to. y over 1 4 f times y squared minus f. Okay, so that, now y over, I can do it as y squared over 4f minus f, right? F is just the same as f over 1, so if I want to get my common denominator, I would multiply the top and bottom by 4f. In other words, I get y over y squared minus 4f squared, which is, that is going to be over 4f. Right? You can see 4f times 4f, y squared minus 4f squared. Now, I just would just do y, or I would multiply by the reciprocal. So y over 1, right? If I'm dividing by a fraction, I multiply by the reciprocal, 4f over y squared minus 4f squared, and I get 4fy over y squared minus 4f squared, which just ends up equaling the left-hand side. So both sides are equal. The right-hand side is equal to the left-hand side. There you go. I mean, this is not really like why it does that. Why it does that is really just because it follows the law of the light ray reflects according to the law of reflection for a little piece of the mirror, and that just so happens to reflect back to the focus. And this math shows us that that is indeed true. Because if you take the slope of the reflected line, it would pass through the point where it hits, and it would pass through the focus. And thus it exists on a point on that line. Boom, it's gonna hit the focus. Hopefully this video kind of made sense. I know this is not I know this is kind of mathy more than anything, like just math work, but that's why it's called geometric optics. It's a lot of geometry, it's a lot of like just math, I guess. I don't know. Shapes, geometry, that's what geometry is about, right? Shapes? I think so. Probably. Thank you for watching.